Hello, AP Psychology, and welcome to our lesson on cognition. Cognition means thinking. I normally put on the board before class a picture or something that highlights what we'll be learning about on any given day. And so for this topic, I generally put up with one of these or two of these. These are actually pretty easy. I know some kids like enjoy figuring them out. They're pretty easy if you haven't done one before. The first one is the word sand in a box, so it is sandbox. All of these represent some kind of saying that's fairly common. You just need to think about it in creative ways. Now, I call this 1.0. This next one, is 2.0. This one is a lot more difficult, and in class, oftentimes we don't even get through all of them because people have trouble figuring out a few of them. But if that's something that interests you, go ahead and pause it and see if you can figure out what these stand for. So like I said, today we're going to be talking about cognition, some basic processes of thinking. I put the thinker man picture of the statue here because that's our topic. So whenever you hear the word cognition, remember we're talking about thinking, and today we'll be talking about basic methods of thinking. So first of all, when we think, we use concepts. The concepts are our basic mechanism of thinking. We don't need to use great detail when we think about every single thing, or our burden of our brain would be overwhelmed. So if I told you that I drove my car to the store, for the most part, it wouldn't really matter to you what kind of car I was driving, or maybe even what kind of store I was going to. So I would be communicating at the basic level. I am currently sitting on a chair. Anything in the basic level shares common properties. So a chair, for example, is something that you sit on. There are multiple kinds of chairs, but just knowing that I'm sitting on a chair, you know that I'm not standing or running or walking while I'm filming this. I'm sitting on a chair. But we do organize concepts into something called a hierarchy. So if you were really interested in what kind of chair I was sitting on, I would tell you that it is a swivel chair. It's an office chair, and it came from IKEA, and it's padded. Some of you might be sitting at a kitchen table chair, or maybe you also have an office chair, or maybe you're even sitting on a big, comfy lounge chair. So the subordinate concepts are where we get into the more detailed level of thinking. Now, most things in a basic level will fall under a superordinate concept. So we have our basic level of car, and the superordinate concept is vehicle. Other basic levels that might fall under vehicle might be a bus, a train, a boat, etc. Those are all things that transport things from one place to another. Chair would probably fall under the superordinate concept of furniture, okay? And then in the basic level might be couch, lounger, etc. Now, when we think, we use prototypes. So I asked you to think of, what do you think of when you think of a bird, when you think of junk food, and when you think of active sport? Now, when I do this in class, I get a huge variety of answers. And when I think of a bird, I think of a cardinal. I love cardinals, and I have cardinals in my yard. They come to my bird feeder. When I think of junk food, I can't think of anything junkier than Cheetos. I mean, think of all of like the orange stuff that comes on your finger, and then you're licking your fingers, and there's absolutely no nutritive value whatsoever. And when I think of active sport, I think of tennis, because that's something that I used to play quite a bit, and it's a very active sport. Some of you might think soccer, some of you might think football or rugby or basketball. The point here is that we think using prototypes. Our prototype is our best example or mental image that incorporates the features we associate with a concept or category. I doubt when you thought of bird that any of you wrote down ostrich or penguin, because these do not have some of the features we associate with the concept of bird, which is to fly. Occasionally, I'll get someone to write down a loon because that is the Minnesota state bird, but that's very rare, and even a duck is very rare for someone to write down as a bird. Again, likewise, like with my example here, when you think of a car, I might think of my family SUV, and somebody else might think of a sports car. It really all depends on that word we've talked about before so many times, your personal schema. I think that's one word that you're going to be really familiar with by the end of the course. So how we think depends on our experience and our schemas, and this is what can lead us into some problems. So how do we solve problems? In class, I like to give a sheet of problems to solve. So I'm going to go over some problem solving methods, and I'm going to give you a few problems to try to solve. One way that we can solve problems is through simply trial and error. This is a saying that you probably haven't heard, but if you work through it enough, you will figure out what it is. And basically, you just have to start sounding out the letters. You have to try putting different combinations together, and you will figure out what it is. Most of the time, somebody in class will figure out what that stands for. So that's one method of solving problems. An algorithm is a step-by-step rule that guarantees a solution. So we know from our math facts that 3 times 4 is 12. We divide that by 10 minus 6, which is 4, and that equals 3. Algorithms are great. They help us to solve a problem. I mean, sometimes I really enjoyed like my math classes because I knew if I had the problem right or wrong. So algorithms guarantee a solution, but sometimes if you're looking to try to find, for example, a doctor using an algorithm, if they try every single diagnostic test that's available, it's going to take a long time. So in order to shorten the time that it takes us to solve problems, we might use something called a heuristic. Now, this is probably a new word for most of you. It is a rule of thumb or a cognitive shortcut. So when we're unscrambling a word such as this one, we might think of some word letters that we normally might see together. We might think of the context, so think about this class and what class you're in right now, and you're going to use a shortcut to unscramble that word. Another heuristic, for example, remember when you were a kid and you got these like books with like mazes and there were like 4 places to start and 1 place to end? Well, how do you find the beginning? You start at the end and then you get to the beginning. You don't need to go through all 4 of them to try to find the end. So that's another example of a heuristic. Now, sometimes we just get the answer through what we call incubation and then insight, the sudden awareness after a period of incubation. So I'll give you 2 examples of some problems that involved this incubation and insight. So here's one. What is black when you buy it, red when you use it, and gray when you throw it away? Now, there's really no particular algorithm that you can use to solve that. There's not even a heuristic you can use to solve that, but suddenly you will get the answer. And by the way, red is spelled R-E-D, not R-E-A-D. So I'm not going to tell you the answer to that problem. I hope you can figure it out. If we were in class, we would spend a whole day doing creative problem solving. I do think it's fun and interesting to solve some of these problems, and perhaps I'll give you some more. Here's another one I can give you. This is a famous story about a hunter who sees a bear 1 mile due south. He shoots, he misses. He walks down to where the bear had been 1 mile due south, and then he sees the bear 1 mile due east. He walks the 1 mile due east from where he shoots and misses and walks the 1 mile due east where he had seen the bear, and then he walks 1 mile due north, at which point he's at exactly the same spot from which he started. So I have a question for you. What color was the bear? So think about that one for a little bit. All right. Obstacles to problem solving. Fixation is when we are bound by concepts, schemas, or prototypes. First of all, sometimes we use what's called a mental set. We only attend to certain aspects of a problem, usually what has worked previously. So I would give you this problem in class. Excuse me. OTTF. What are the next 3 letters? So you can pause and think about that if you want. Okay, the next 3 letters are FSS. This is why. 1, 2, 3, 4, 5, 6, 7. The first letter of each of the first 7 numbers is what this pattern is. So when I give you this, you're already thinking, oh, that must be the first letter of something. So what could it be? Well, it's MJJ. And maybe you figured that out already. January, February, March, April, May, June, July. So mental sets do help us solve problems quickly if something has worked in the past, but they can also be a problem because, for example, I have 4 kids. If I tried to teach all of my kids exactly the same way, it's not going to work. So something that might have worked with my oldest child maybe wouldn't work with my 2nd child or my 3rd child or my 4th child. Even as teachers, we have to be flexible like we are right now. Some things that worked for us previously aren't going to work for us during distance learning. And this is something that we need to be aware of and try to be open to new kinds of experiences. The other thing that often gets in the way of our problem solving is something called functional fixedness. We think of an object only in terms of its usual uses. So an example I could give for this are, what are the uses for a brick? How many things can you think of for a brick? Now wait a second, I have another thing to show you. So, sometimes your hair just really bugs you. Like if you have long hair, you just know, like, oh dang, I just want to get this hair up. It's like really bothering me right now. And dang, I don't have a binder. So what can I use instead? Oh wait, I can use this office clip. And there we go. Yes, you can officially call me strange, but that works pretty well. It doesn't look so bad either. So that's an example of not being functionally fixated, by being creative in problem solving and using things that we haven't used before in a unique way. So I'm going to give you a little story here, a little problem that is often difficult to solve because of functional fixedness. John and Mary are alone. I'm sorry, let's start over. John and Mary are in a locked room. They are dead. There is a puddle of water, a chair, a dog, and broken glass. How did John and Mary die? I'm not going to give you the answer right now, but see if you can think of it. And one of the problems that we have with this one is functional fixedness. We think of things in a certain way. Sometimes we attend to irrelevant information. One of the examples I give in class is Susan is traveling from Boston at 50 miles an hour. Ellen is traveling from Washington, D.C. at 45 miles an hour. The trip is 200 miles. Who is closer to Boston when they meet? Well, the key here is that they met. So they're both the same distance from Boston. And sometimes we look at that and we think, a problem like that, we think, oh, we've got to use a math problem or something along that line, and people start getting out their calculators, but it's just a pretty simple problem. Sometimes we just overthink. And then finally, unnecessary restraints. Sometimes we don't think outside of the box, and this is something that you can read about more in your textbook, but keep in mind, thinking outside of the box, trying to think creatively is going to help you overcome your obstacles to problem solving. Thank you for listening today. Have a great day.